In the diagram, A has the coordinates 3 and 4, B and C are vertices of triangle A, B and C. Line A, B is produced to S, D and F are the x and y intercepts of A, C, respectively. F is the midpoint of A, C, and the angle of inclination of A, C is alpha. The equation of A, B is y equals to kx plus 3 and the equation of A, C is equals to 2x minus 2.
Question 3.1. We are supposed to show that k is equals to 1 over 3.
Pause the video and give it a try.
Firstly, we are going to equate the equation of A, which is y equals to kx plus 3, and the equation of AC, which is y equals to 2x minus 2. We are equating this to equations because the two lines have the point of intersection at a 3 and 4.
Kx plus 3 will then be equals to 2x minus 2. And, since we already know the x-coordinate of the point of intersection of the two straight lines,
the x-coordinate of the point of intersection of the two lines is x equals to 3. This x-coordinate is found at A, where there's x we then substitute 3, giving us 3k plus 3 equals to 2 times 3 minus 2, giving us 4. Now solving for k, we then transpose 3 to the right of the equal sign, giving us for minus 3 equals 1. This implies 3k equals 1. Divide by 3 both sides, therefore k equals 1/3. Question 3.2. We are supposed to calculate the coordinates b, the x-intercept of line, with the equation y equals kx plus 3.
Pause the video and give it a try.
Since we know from this line we already calculated the coefficient of the line k equals 1 over 3, giving us the equation y equals 1 over 3x plus 3.
Remember, we are supposed to calculate the x-intercept of line with the equation y equals 1 over 3x plus 3, finding the x-intercept of a function. We let y equals 0, giving us 0 equals 1 over 3x plus 3, transpose 3 to the left of the equal sign, then cross-multiply. Therefore, x equals minus 9.
Therefore, the coordinator of b will be minus 9 and 0.
Question 3.3, we are supposed to find the coordinates of C. First things first, let's look at where C lies on the diagram, and which equation of straight line we are supposed to use. The equation of straight line where C lies is y equals 2 to x minus 2, whereby in this straight line we have D as the x-intercept and F as the y-intercept of this straight line. As the statement reads, D and F are the x and y-intercept of line AC respectively. Finding D, the x-intercept of line AC, we let y equals 0. Giving us 0 equals to x minus 2, transpose negative to the left of the equal sign, therefore x equals 1. Giving us the coordinates of D as 1 and 0. Now finding the coordinates of F, the y-intercept of line AC, we let x equals 0, giving us y equals minus 2. Therefore, the coordinates of F will be 0 and minus 2. From the statement, we are further given that F is the midpoint of line AC. Given this information, try finding the coordinates of C.
Pause the video and give it a try.
Using the midpoint formula, we are going to find the coordinates of C. We know that F is the midpoint, and given by the coordinates 0 and minus 2, equal to x1 plus x2 over 2. And y1 plus y2 all over 2 can also rewritten as xc, y and yc. Make sure you don't get confused there. I made a mistake by using d as a variable, not c. Make sure you fix to that. In the x and y coordinate of a, we substitute 3 and 4 respectively. and then equate the x of f with the x-coordinate of the midpoint formula 3 plus x over 2, giving us 3 plus x over 2 equals 0. Then solving for x, we find x equals minus 3. Do the same with the y-coordinate of the midpoint formula for plus y over 2 and then equate the y of f, giving us for plus y over 2 equal minus 2. Then solving for y, we find x equals minus 8.
Therefore, the coordinates of point C will then be negative 3 and negative 8. Question 3.4. We are supposed to determine the equation of the straight line that is parallel to BC and passing through point S, minus 15 and minus 2. In these questions, we will have to firstly note that parallel straight lines have equal gradient. Before we get into calculations, let's firstly understand what is a gradient. A gradient is a measure of the steepness of a line or the measure of the slope. The formula shown on the slide is used to measure a gradient. Using the formula gradient and point S given as minus 15 and minus 2, find the equation of the straight line. Just give it a try.
Pause the video and give it a try.
Since we already calculated the coordinates of B as minus 9 and 0, and the coordinates of C as minus 3 and minus 8, using the formula of the gradient, we will then substitute the coordinates of B and C, giving us 0 plus 8 all over minus 9 plus 3. Giving us 8 over minus 6. Therefore, the gradient of line BC will then be negative for over 3. Now, since we are given the point S with the x-coordinate minus 15 and y-coordinate minus 2, and we also determine the gradient of the line to be equal to negative for over 3, we can use the equation of the straight line y equals mx plus c, giving us minus 2 equals negative for over 3 times minus 15 plus c. Negative for over 3 times negative 15 will then give us 20. This implies minus 2 equals 20 plus c. Therefore, c equals minus 22.
Question 3.5. We are supposed to calculate the size of B, angle at C.
Try this question on your own. Don't fail to try.
Pause the video and give it a try.
Before we answer this question, let's try understand what is the angle of inclination and deprivation of the formula m equals tan theta. Since we know the formula of the gradient given by rise over run, simply meaning y to minus y1 all over by 2 minus x1. Since we also know from trigonometry that tan alpha equals opposite over adjacent. By the way, in this case, rise over run 2, simply meaning y to minus y1 all over by 2 minus x1, and from this we can conclude that m equals tan theta.
Using m equals tan theta, we are going to determine the angle of inclination of line AC, represented by angle alpha.
Using the equation of line AC, we already have the gradient as 2 equals tan alpha, solving for alpha equal to arctan of 2. Therefore, alpha will be equal to 63.43.
Now let's consider a negative gradient. Alpha will be equal to negative 63.43 degrees measured clockwise. Therefore, the angle of inclination of the negative gradient will be 180 degrees minus 63.43 degrees.
Now back to the question with the angle of inclination of the positive gradient, alpha equal to 63.43 degrees.
The exterior angle of a triangle is equal to the sum of the two opposite non-adjacent interior angles. Let's let E, angle B, D, be beta. Using the same formula of the angle of inclination, m equals tan beta. Well, in this case, we already know our gradient k equal to 1 over 3. Now let's find beta. Beta will then be equal to arctan of 1 over 3, giving us 18.43. The exterior angle of a triangle is equal to the sum of beta and angle A, this simplifying to I plus beta equal to alpha. Therefore, I is equal to alpha minus beta, giving us approximately 45 degrees.
Question 3.6. If it is further given that the length of AC is 6 root of 5 units, we suppose to determine the ratio of the two triangles AABD and AASC. The area rule states that the area of a triangle is half the product of two sides and the sine of the included angle. For example, area equals 1 over 2 B, C, sine A equals to 1 over 2. AA, C, sine B equals to 1 over 2. A, B, sine C.
Consider triangle ABC, and in this triangle we are going to construct a perpendicular height, h. By the aid of trigonometry, the sine of angle B is equal to the opposite side of the angle, which is further given as the perpendicular height, h, over the hypotenuse, c, and by making h the subject of the formula, h equals c sine of angle B. Since by now we already know that the area of a triangle is equal to half breadth times perpendicular height, our perpendicular height, h, in this case is equal to c sine B, and our breadth is AA. Hence giving us a times perpendicular height, h, further giving us a times c sine B.
We are going to be using the area rule that states that area of triangle ABC is equal to 1/2 of sine C, and the distance formula to determine the required length of the unknown sides. And using the distance formula for determining the length of as, we then find the distance to be 6 root 10.
And we already have the length of AAC, given as 6 root 5.
Using the area rule, 6 root 10 will then multiply 6 root 5 times sine AA, which is approximately 45 degrees. Also, for triangle ABD, we are going to use the same procedure. For triangle ABD, we are going to use the distance formula to find the length of AAB and AAD.
Try finding this to lengths AAB and AAD.
Pause the video and give it a try.
Using the distance formula, we then find the length of AAB to be 4 root 10 and the length of AAD to be 2 root 5. From the area rule, we are now going to multiply 4 root 10 to root 5 and sine 45 degrees, giving us 8 over 36, equal to 2 over 9.